a thing that would help us. And so let's start with abstraction. And I believe the first group that I assigned that to was Daniel, Drew, Hash, and Tyler. Whoever was the person that ended up being, can you define for me what abstraction is? And I'll put this here in my notes, and I'll share this out with you at the end of the class.
I would love to share since I won the last name game, Mike.
Fantastic.
So we found a couple slightly different definitions, one from Turing and a couple online. Essentially, it's just abstraction is hiding complexities in your code or complex code either into simple verbs / methods. So like as long as you have a good name for your method that makes sense, people don't have to know what's inside of the code per se. And then a couple things online mentioned hiding complexity in the code from users, like using like apps as an analogy. So
can you say more about hiding apps, like apps? Say more about that.
Yeah, so like there were a couple examples. Let's say what was the first one? I can't remember. So there was an Uber example where like whoever is using the Uber app in order to get a ride, you just have to type in your current location or even hit like the find location button, tell them where you want to go, and then the Uber app will spit out the time and price, and you click, you confirm that with them. The user has no idea what's going on besides clicking a couple buttons on the app.
Cool. I think go ahead. Sorry, I didn't want to interrupt.
Well, I had a couple examples that we came up with if you want me to jump into that.
Nope. Let's I'm going to give the other groups opportunity to talk too. I think a good example that I use repeatedly of abstraction is the car, right? In that they've abstracted a lot of the functionality of the car from us. Like, do I need to know the inner workings of transmissions and the internal combustion engine when I, drive a car? Like, no, I step on the right pedal to go and the left pedal to stop. And we can hide a lot of complexity. Like when we think about that, we can use like the same kind of interfaces. Like when we think about like electric cars, they are radically different in many ways and shapes from like a standard fuel burning car. But at the same time, you got a wheel, you got a pedal on the left and a pedal on the right. Did I just say earlier that the gas pedal's on the left?
No, you said it correctly.
Okay, cool. It's like one of those things where like I think that if you've driven a lot in your life, you don't even think about it. It's just like your body just does it. You don't really, the gas is on whatever it is. The gas gets stepped on by my gas foot. That's what I'm calling from now on. So Chris, Dan, Nico, and Sarah, let's talk about encapsulation. Let's get a definition of encapsulation together.
Absolutely. So we came up with a couple of different definitions, but for the sake of brevity, I'll give you the one I think that probably works the best. Is a concept that binds together the data and functions that manipulate the data, and it keep both safe from outside interference and misuse.
Outside manipulation?
Yep, and use or misuse.
Misuse. Cool. That's great. Anything else you want to add to that?
We put together a list of advantages.
Sure. Let's talk about some advantages.
So, security, kind of implied there with misuse, it allows a class to have more control over its attributes and methods, which will help with debugging, reduces complexity, helps to keep things organized, and just generally keeps things more simple so that it functions more like an on-off button so that people aren't inclined to go and mess with it because it's kept simple.
Cool. All right. Let's talk about inheritance. From Angela, Philip, Roberto, and Brian.
Hi, Mike. I think I won the last name game, but
yeah. You know what? You all are winners.
We're all winners?
Everyone's a winner.
Wonderful. But for our group, for inheritance, it describes a relationship between two classes. Usually when a class goes from general, like a general class to a specific class. And what that means is that the general class will have, you know, let's say we have a dog class, and then we have two child classes like German Shepherd and Chihuahua. German Shepherd and Chihuahua
Man, I don't
can
know how to
inherit
spell
from
Chihuahua.
dog. Maybe I should have said Yorkie. Be sure.
Thank you.
All right. So those two specific classes, subclasses, inherit from the parent dog class.
Mhm.
Yeah.
Why? Why do we do this?
This dries up our code significantly. So all of those methods, like if run, for instance, was a method in German Shepherd and Yorkie, we could extract that to the parent dog class. And then, so now you reduce the amount of times you're repeating yourself in all of those child classes. And you can also overwrite methods. Like, for instance, one example that I think Philip, you brought up was with penguin. Like, so if we had a bird class and we had a penguin class, penguins can't fly, but you can override that. There's ways to do that.
Cool. Excellent. Thank you. Corey, Luke, and Travis, let's talk about the big polymorphism.
Such a fancy word, that polymorphism.
It's so good.
You break it down, it means many forms, as we pointed out.
Many what?
Forms.
Mhm.
So basically, polymorphism is just this idea that something can take multiple forms. So for instance, like a vehicle, you could have three different classes: vehicle, car, and truck. And you can create new instances of that vehicle class being like vehicle equals truck.new or vehicle equals car.new, knowing that they have similar shared behavior, basically. And then there was another new concept that we hadn't heard before until this called duck typing.
Yeah.
Yeah, where basically as you're writing your code, writing your methods and everything, if it walks like a duck, it quacks like a duck, then it must be a duck. So meaning if you are creating a method for fly for an animal, you can apply that to, you know, you can apply that to a swallow, you can apply that to a duck, but you cannot apply that to a whale, for instance. So you would not use that same bird class, for instance, to describe or instantiate a new whale.
Cool. Cool. Great. That's fantastic. Let's talk to the next group and let's give us an example you found so far of abstraction. Dan, Lee, and Logan.
Well, there's a couple of different things that we came up with. Do you want like an example as far as related to like coding?
Yeah.
Or just abstraction in general?
Yeah. Can you give an example of a place that you've a place that you have used abstraction previously to now?
Well, I believe that we've probably used abstraction like whenever we use mini-test, like we're abstracting from test, I think.
Say more.
Well, when we reference mini-test, like mini-test we're inheriting from mini-test, and mini-test is test is a module for mini-test.
Okay.
So I would assume that essentially it houses all of the complexities that really we don't need to necessarily know. We just know that when we call those things that they do the things that we're expecting them to do. In like a real world situation, like a calculator, for example, like we don't necessarily know what's going on in a calculator when we're trying to compute a whole bunch of things. We just care about the answer that we get. Or a coffee machine. Like it makes all kinds of noises and it brews and does all these things, but at the end of the day, all we care about is that we get our coffee. You said car earlier. I guess our cell phones could be another example. We just know that we push certain buttons to have it do the thing, but we don't necessarily know what's going on under the hood.
Cool. Fantastic. Enrique, Hope, and Sean, how about some examples of how we use encapsulation?
Yeah, so I won the game of last name, and encapsulation, some examples we came up with were actually like classes. So just kind of the I think another kind of smaller form of encapsulation are like def methods. Like when you define a method, you are in fact encapsulating
Mhm.
a smaller form of function within a larger form of class. And the
Can you say
main
that one more
log,
time?
just a smaller functionality into a larger like class. Right there, all these pieces come
Mhm.
together to make this kind of this class its best self. And I think one of the words that we really liked, that we definitely, oh no, from manipulation and misuse, that was definitely like, as far as like keeping our code safe from outside manipulation and misuse, which is said on the first line already. I think part of how we thought about that, how we have thought about that is scope. Thinking about like, how are our classes talking to each other and how do we set that up in a way that's like meaningful and
So can you give me an
useful.
example? Can you think of one way in which you are currently already protecting your code from manipulation and misuse?
All we could talk about was our project and like how our like averages wouldn't net our methods are tested in relationship to a very specific set of data. And so if we were to introduce, say, another set of data, like our tests would fail and our methods might not be, maybe they would work, maybe they wouldn't. But I think like the fact that we had like protected our CSV files into objects that we can now like access was a way of making sure that like, all right, if there's another set of data that we would get, we'd have to logically build that class and have it interact with what we have already in a way that, I don't know if this is helpful at all, actually. I don't know if I can stick this landing.
Yeah, so I think the idea is like, one thing I kind of want to mention is like, you know, you've been doing something to kind of protect your code with from outside misuse through encapsulation already. Like I think one thing I've mentioned to you over and over again is like, when do you use adder accessor? When do you use adder reader? Like only when you need to, right? So when you're doing those things, you know, you're encapsulating the data within an object and making sure that you're only giving it the access you need to. Cool.
That makes a lot of sense. Yes.
Inheritance. That is when we get in Priya.
And you wanted some examples, right?
Yeah, some examples where we've used this so far.
So we were thinking about the library independent challenge.
Huh?
And, or whatever it was, maybe mid-month, I don't remember. But
who knows? What is time anymore?
Exactly. So Garrett and I had kind of discussed that, like, hey, if we had a library superclass, then we could have inherited to individual types of those libraries, like the DPL at Wadsworth and 44th. I'm making up streets. I don't know Denver that well. Or, you know, the Brighton Public Library or whatever. So like you could have separated out individual library classes, subclasses or child classes that would have inherited all of those same traits, concepts, you know, would have held collections, libraries, authors, books, whatever. And then we had a whole conversation about inheritance versus module because that was easier for us to understand.
Okay.
And so like we talked about like, okay, well, why would there be a library superclass versus like modules? And so we thought maybe the library superclass would hold like instantiations of books or collections or authors or whatever we need for state, whereas our modules might hold repetitive behaviors like, sorry, I just caught Corey's background and it distracted me.
All right, now I have to look at Corey.
So sorry.
That's good. That's good. Well played, sir. Well played.
But So like the method, the module might be like the action of adding a book or repairing a book
Yeah.
or checking out or something.
Fantastic. That's a great example of it. And also, Brett and John, let's talk about polymorphism. Have you used polymorphism already?
I'm not 100% sure that we have.
And that's
but
fine.
Things that I do have kind of written
Yeah.
down is that you're able to send the same message, so use like the same method name to different objects to get different results. So it's kind of the idea of going into inheritance almost. And if you had, maybe like an animal class that had the method speak, when it's passed down to dog would be bark. Whereas if you passed it down to a cat, it would be meow.
Fantastic. I think that like polymorphism is one of those things that we don't really use too much in the projects at Turing. I think that like to use them here is a bit of, I think you have to stretch to use it. And I think that the kind of like the big picture thing to take out from polymorphism is that there may be a point where you don't really care what kind of object you get back if you're calling a method on. Like, do I care? If I get, let's say you have like animals and you feed animals, and when you have a feed method on the animal, it makes their hunger go down to 0. And so you may have a zoo object that is a collection of animals, and you may iterate through the animals and run .feed on them. And like, as you're doing that, do you really care about what kind of animal object? You have a cat, a dog, a hamster, other animal. Like, we don't really care about like what object we are feeding, as long as that feed method we're getting. Oh my gosh, I'm sorry, I just looked at the DK's background, and it's like it's like backgroundception. Oh, now I've lost the train of thought. All right, I'm gonna move my window so I can't see it, and I'm gonna collect myself. Okay. We don't really care about the kind of object so long as it has that method that works, right? And that falls in this kind of idea of duck typing. Cool. And that kind of wraps up the 4 principles of OOP. I think that these principles are also called pillars, and these are, I think that other people may call them like the 4 characteristics. Like, these are the 4 things that defines a language as being object oriented. And kind of at this point, I'd like to open it up to questions from everyone about these 4 things in particular.
So would you kind of build your code based off of these 4 pillars, or just kind of like as a blueprint to make sure that they have all of these?
I don't think I would use blueprint. I don't think I'd use the word blueprint. I think that these are big ideas that will help your code become clean, easy to read, dry, conform to like kind of the way we build code. But like, the word blueprint for me kind of, it makes me feel like I have to use these things. Like I have to. And the thing is that you don't have to. Like, for example, polymorphism.
So they're like theories, I guess.
Yeah, like the things that, like polymorphism, like I don't feel that like I would go do something and make it polymorphic just to be polymorphic. Does that make sense? Like, I don't need to, but it is a strategy in order to make our code work better and more cleanly, right? It's like, I think that polymorphism applies in very specific instances, and it will solve some problems you have, but like, you don't need to reach for the tool. Like, it may not be necessary. For example, like if you are running an animal shelter and you have some dog, oh, that's a bad example. Your football class, your football project, right? Like, is there an opportunity to use polymorphism there? Probably is, But do you need to go out of your way if everything works fine and is generatively well-written code? No. I think that that's why I feel like polymorphisms, like everywhere I've seen polymorphism is always like the last one on the list, because I feel that that's the one that, no one really uses, that is not always used. For example, we go up to the list, we see abstraction, like, oh, abstraction makes sense. It keeps our method short. It makes things adhere to SRP. If we're abstracting correctly, we're also drawing out our code. You're like, yeah, abstraction, I get it. Encapsulation, yeah, we're using encapsulation every single time we create a class. Every single time we write a method, we're using that. Inheritance, yeah, like in Ruby, we're really using inheritance in terms of like that lookup chain that we kind of talked about. With scope, like, oh, if I don't have this method here, I'm going to look for a sibling method. If not, I'm going to look up the chain. Like, yeah, we are using inheritance under the hood, as well as like we can overtly use inheritance, like when we have classes and things inherit from each other. So that gets used. But polymorphism is not necessarily something that you would create. It's something that you do use under the hood. For example, like there are methods that work on multiple classes. For example, I think, let me pull up a term. Can you see my screen okay? My terminal? Nope. Length. I think this is a good example. Yeah. And this is, I think this is something that polymorphism is built into Ruby, right? We have the same method length. It runs both on a string and an array, right? So it is there, but it's not necessarily something we're using, right? Cool. Other questions, comments about this today?
So would you say that like these pillars are maybe structures that we can use to better
one, yes. Two, I don't know if I'd use the word structures. I think maybe patterns is a better.
They could help like the dynamic, making code more dynamic, especially as it starts to grow.
Yep.
Okay.
Cool. All right. If that is it, you're all set for now. Let's break. Let's be back around 10 o'clock for the next chunk of this.